For us traditional storage admins, Kubernetes can be extremely complex at first glance. I myself am pretty new to Kubernetes and containers, so if there's an easy way to administer it and to learn it, I'm definitely game on. As always, do click subscribe if the content makes sense and feel free to leave me any comments. The current buzz in the industry is definitely around containers. It's always about container this, container that, and how it integrates with containers and so on and so forth. Specifically with regards to storage, when it first started, containers were largely ephemeral, and that simply means they were stateless and they didn't need to have persistent storage. But as time would have it and evolution happens, there is more and more requirements from the developers community to have storage as persistent. I'm sure you guys have heard all the buzz around VMware's Tanzu offering and the various stuff that we are doing around containers. But have you heard much about vSAN and Kubernetes? Let's take a look. So let's jump into the monitor tab, scroll down to capacity. Let's expand upon the VM sub tab here. So within this VM sub tab, we will actually show the actual consumption by the primary VMs, or rather just the normal VMs. We show primary data and replica usage. There's also a subsection here on block container volumes. Understandably, this is pertaining to the new feature that we have around Kubernetes storage and storage for containers. You can actually expand upon this under this section here on container volumes overview. This details every single PVC claim or persistent volume in the Kubernetes environment. As you can see, it can be a little bit overwhelming, but don't fret, because Kubernetes actually allows you to do some tagging, and we ingest those tags in there as well. So if you expand upon see all, you will see it tagged against an app, MongoDB in this case, release, Rocket Chat, so on and so forth. So assuming a developer comes to you and say, hey, I have an issue with Cassandra. What you can do is you can go filter here, type in app, Cassandra, and there you go, that one PVC claim pertaining to that pod. Assuming there's a request that comes in that requires the Cassandra database or Cassandra environment to scale out. So how do we do this? As a developer, let's bring up the Kubernetes GUI. If I hit Cassandra here in the namespace, scroll down under persistent volume claim just to check. Yes, as expected, there's one PVC claim as reflected in vCenter. Let's go into stateful set, hit Cassandra. And yes, there's a single pod. Assuming, like we discussed earlier, we want to scale this up to a few more pods. The key word here is once you scale out the pods, all those volumes are dynamically created. You don't actually have manual interventions where you need to go create a VMDK and attach to the pod individually. So let's try to scale this out. So let's design number of pods, maybe let's go with 3. So it takes some time to call upon vCenter and start creating volumes on vSAN. Let's let's do a refresh, see where we are at. Here we go. Just hit refresh again. All 3 pods are up. So let's validate this as well. Let's go under persistent volume claim. So good. So we have 3 PVC claims against those 3 pods. Let's go back into vCenter and validate this. So let's do a refresh here. Cool. So you can see here we have all 3 persistent volume claims against that 3 scaled out pods. You can actually get a little bit more details as well if you need it. If you hit details here, you will see we tag it to the particular Kubernetes cluster, assuming there's many Kubernetes clusters in the environment. Maybe sometimes there is also a clash of names. That's where this particular PVC claim ID comes useful. Assuming, again, the developer has an issue with a volume, all they need to do is provide you this long string, and you can filter it like how I did the app filtering for Cassandra earlier. If you go into basics, it shows a little bit more details. Where is this particular pod or this volume, persistent volume claim is hosted, vSAN data store, and then obviously because it's running on vSAN, there's a policy associated to it. If I want to dive a little deeper, given that it is vSAN, I can jump straight into the placement details as well. So this gives me more detail as to where this particular data set lives, into which node, down to the point of which capacity drive. So what's your thoughts? Frankly, I thought it was pretty simple. I mean, at least the first time I done it, I thought it was extremely simple. It was no different than how we would probably do it on a VM. Hopefully that demo has given you a little bit of an insight of how vSAN interacts with Kubernetes and how do we provision and manage. Till next time,